This is Kevin with CommercialLEDlights.com. I'm joined here by the owner of Commercial LED Lights, Charlie, as well as our lead engineer, in-house engineering expert, Peter. How are you guys doing today?
Just fine.
Doing well, Kevin.
Thank you very much.
Good. Today, we're going to be talking about pole loading charts, EPA ratings, in general, how to properly select a light pole. This is critical for things such as safety, code compliance, and preventing failed installs or liability, particularly in windy regions. This will come into play. So let's start by determining the lighting requirements and layouts. I'll hand it over to Peter here, our engineer.
Okay, thank you, Kevin. Everything starts with the photometric. The photometric, you determine the average foot candles that are required for the project, and the uniformity. That dictates the number of poles and the pole height. So out of a photometric, you're going to know the number of poles and the height of the poles and the number of lights per pole. Then we go to the next step.
Yeah, after, like Peter mentioned, we have the lighting design taken care of. There's other things that you might want to consider that customers need outside of lighting. Are there signs? Are there cameras? Are there any decorative elements that people want to hang on it? So it's really important to understand everything that goes on the pole, because oftentimes the scope does go outside of lights. Additionally, on top of poles, usually mounted to the top or the sides, there's often other tenons or other attachments that might need to go on the light as well. A bullhorn, for example, if you're mounting 2, 3, or even 4 lights on a pole. So that is the next step in terms of determining what pole you need. As you can see, there's a lot that goes into it.
One thing I didn't mention coming out of the photometric is also the type and size of light, which relates to the weight. And then you get into something called the EPA, or the effective projective area, which is how they determine the torque that is on the pole. It's basically, you have the wind pushing on the pole and the light configuration, and that creates a moment on the base of the pole, and you got to make sure that the pole is designed to withstand that maximum moment so it doesn't fail. So typically what you would do is you would get the EPA. You don't want to calculate it, or if you're an engineer, you can calculate it. But you can get it from the light manufacturer. They'll supply the EPA or the effective projected area. And once you have that, then you go to the next step.
So the next step, once you, like Peter mentioned, we've got the design done. We understand how much pressure is going to be on these poles, given the area of the light, which is really important. It's less weight, more area. You have to determine the wind speed in the area, and there are in wherever these are being installed. And there are resources that, with zip codes, cities, a variety of ways, we can find out what the maximum wind is in that area. So from that point, we are going to be designing the light to that maximum wind speed. On top of that, there's also something called exposure categories, which are even deeper down into just, an area can have 180 mile an hour winds or 120 mile an hour winds. And a lot of that is topography. Is it in a coastal area? Is it mountainous? Even the Great Lakes has their own category, for example. So it starts broad, and then you narrow it down to even regional, geographical, topographical elements that we're going to be up against.
And high wind areas require its own specific type of pole, right?
Definitely. A good example of that is, now that we've figured out all the variables, we need to select a pole. We have to figure out what do we need to do. So material and thickness and shape are going to be the main drivers of what we're going to select. So there's a lot of poles. There's a lot of pole manufacturers we work with, and they have a lot of, we call them stock poles, if you will. But we also work with custom pole fabricators that will actually design to very high wind areas. And a good example of that, of a project that we've recently done that Peter designed, is down in the St. John Islands in the Caribbean. These poles are extremely thick. They're also galvanized, and these are a custom-made design for this application specifically. Now that we've gone through this process, we can get these poles designed and start the manufacturing process.
Once we know the height and the number of lights per pole and the EPA, what you would do is go to the manufacturer's table, which relates pole height, and you can then select, well, you know the EPA, then what you would do is determine the wall thickness or the gauge, the diameter or the square, and typically you have either a 4 or 5 inch diameter or square pole, and under the extreme cases where you have to design a pole to withstand hurricane winds 180 miles an hour, you can go up to a 6 inch diameter or square, and then you would go with the lower gauge. Lower is thicker. And so they basically have a table which correlates all this information: the EPA, the height, the gauge, and the diameter, and then you pick out the skew of the pole that gives you the protection based on the max wind rating. So there's no calculation. You just take a look at the table, and then you can select the pole that meets the max wind requirement.
So really the last thing is you've got to anchor this pole in some manner. And then we would verify the foundation, the anchor points, send those to typically the contractor, and they go about pouring the footing, putting in the anchor bolts that we provide, the anchor bolts, the template, so they can get all that buttoned up. And then there's also some other kind of accessories, if you will, that some poles need. If there's like certain types of vibration, there's dampers for those. There's certain specific grounding methods for the electricity that also might need to go in, and all these things will need to be considered for, extreme fatigue, ice loading, and even seismic requirements. So again, that's going to be out in maybe California, where we have to be aware of earthquakes. So that's another element that needs to be taken into consideration. That is poles in a nutshell, and it's pretty nuanced, as you can see.
As you can see, there's a lot more to selecting a pole than just saying I need a 10-foot or a 30-foot pole. A lot of things come into consideration, such as wind in the region, EPA, how many fixtures are going to be for poles. So it's highly recommended that if you're considering a parking lot lighting redesign or lighting a coastal region, that you consult with an engineering expert to determine what kind of pole would be applicable for their project.
And we've gone through a number of projects, and we've done this extensively over the last number of years. So we're the experts in this area.
Absolutely. Well, thanks for all the information on poles, pole wind ratings, EPA, etc. Appreciate it. And until next time, guys.
Thank you.
Thanks, Kevin. Thanks, Peter.